Vercel is a popular website that to instantly host, build, and scale web applications. This is an article written by the engineering team. They have been using agents extensively to build and plenty of lessons to learn from them. And this is really a very nice, pretty interesting post that just has the right set of nuggets that gets to the heart of why building with AI can get dangerous in production. So I'm going to do a quick overview of this article and recap the lessons so that it's useful for what is well known at this point is that AI generates code at unprecedented speeds, and in the hand of disciplined engineers it's good, but without rigorous judgment they are a highly efficient way to ship bad assumptions directly to production. So the code is dangerously convincing. It comes with a polished PR written as if it looks as if it's written by an experienced engineer, but in contrast it fails to understand the minute, the implicit assumptions of your development environment and production environment. And so even though it looks very convincing, like a senior engineer would write, but it fails to understand what the implicit assumptions are. So that leads to false confidence. And if you trust that code, you are in for a surprise when you deploy them. For example, it doesn't know that the Redis instance is near capacity. These are some of the practical issues that they ran into, or that the code hard coded the database to a specific region. Very minute, very implicit assumptions that a senior engineer who's fully aware of how the system is deployed would implicitly take care of by writing the code, but the agent fails to do that. So the gap between this PR, I love this line, the gap between this PR looks correct and this PR is safe to ship has always existed, but agents widen that gap by producing code that looks more flawless than ever, while remaining entirely blind to production realities. So gap between PR looks correct versus safe to ship. What an engineer should aim for is safe to ship, but when burdened with so much code, it's very hard to keep all the assumptions in mind, and tempting to let the code pass if it passes the test and so on. And this is the tight psychological battle that every engineer has to fight when building with agents. So the next lesson is very crisply said here. Leveraging versus relying. So what does relying mean? Relying means relying means being deluded by the agent's code into trusting it fully, assuming that when deployed it will work perfectly fine. The author never builds a mental model of the change, so let alone take the ownership. They just trust the model and the agent, and they're deluded into shipping that code. Leveraging, in contrast, means using the agents to iterate quickly while maintaining complete ownership of the output. So the litmus test is simple. Would you be comfortable owning a production incident tied to this pull request? Now if you ask that question for every pull request that you approve, you're automatically going to have a higher state of responsibility, have a better mental model for what's going to happen, what's going to be the impact of this diff, and that's exactly the mental state that they want an engineer to be in. Instead of relying, being deluded by the correctness, they want to use the agent like a tool at most. The tool should help them leapfrog through the grunt work, but no more than that. They want the engineer to have full ownership of the code and the impact that a diff might have. So solution, so they've laid out a bunch of solution and the mental model, but what do they do in practice to first, don't stop using agents. That the productivity gains are terrific. So AI assisted code review analysis will help catch bugs and surface risks that humans make. So it's undeniably useful, but solely relying on the review is a losing battle against so much code. So what do? They have a bunch of useful principles. So these are, in my opinion, targeted to deployments. So be careful when you're shipping code, but have a highly autonomous infra environment. That's the key message here. So self-driving deployments, every change rolls out incrementally through gated cascade pipelines. If one state detects, it's rolled back. Okay. Then there's continuous validation. The infrastructure tests itself continuously, not just deploy. So by extensively testing and different stages of deployment, they are able to catch the code that violates very quickly. And finally, executable guardrails, not just rules in the documentation, but the guardrail safe rollout generates a rollout plan with rollback conditions. If there's a bug, how to verify the expected behavior, and how to roll back if there's an error. So these three rules applied at the infra deployment time helps them build a very highly monitored infra which catches these bugs quickly. The end game is a world where infrastructure itself is rigorous. That's the key learning they have to save your infra from agent generated bugs which missed human inspection. You need to have infra which is extremely rigorous. So they're investing in a bunch of things at different levels, having static checks, better static checks at PR time, having stronger guardrails around shared infra, production mirroring, end-to-end testing, this cascaded thing, read-only agents that continuously verify system invariance in production. So infra automation seems to be the key message here, and a bunch of new metrics that detect how many defects have escaped human approval, and that gives them an indication of how much the risk is increasing across the platform. Again, the key message: leverage agents, don't rely on them. It's going to be really hard to distinguish between PR that looks good versus safe to ship because sheer volume code. So the key takeaway is that leverage agent, but don't rely on them. And this is in my opinion, definitely a psychological battle that every engineer needs to face and to win against them. Another way to say is ruthless judgment over what they ship. So instead of putting effort on writing good code or doing the task well, the effort now shifts to ruthlessly examining the diff, the change that you wrote, the PR, the code that's being shipped, and ruthlessly examining it, make sure that it doesn't violate any of the implicit production assumptions. So they put it in terms of these three questions, which are wonderful. What does this PR do? How does it behave? Being a mental model, how does it behave when it rolled out? How does it adversely impact production of customers? You think through all the way to the impact. Am I comfortable owning an incident tied to this code? They said that this is a litmus test. If the answer is yes, you're leveraging AI, ship it. If the answer is no, you have more work to do. So that's a wonderful article with points out the deep issues when you are, how easy it is to rely on agents and not leverage them, and that leads to production chaos. And the learnings are to build infra that is autonomous in many different ways, keep checking invariance in production in all possible ways, and again the key message is that leverage agents but not rely on them.